Hey, what's up, everybody? In this video tutorial, we're going to be taking a look at how to replicate all the the circuitry that goes with our LED flashlight keychain from this project. And we could easily go out and we could bring all of our components in and breadboards and wiring, and we could do the physical way of sort of demonstrating all this and doing some learning with it. But there's a really cool thing that's out there with TinkerCAD that we could totally just bring that in, and it's available to students. It's totally free. In which they could kind of play around and get a pretty good understanding of how this all sort of works. Um, so let's just take a look at that. All right, it's a great time. It's a lot of fun to sort of play with and work with. So once we bring up TinkerCAD, many of us probably know TinkerCAD from the standpoint of going out and creating 3D models with it. You can see some examples there, but circuits is going to be one of those things that we can do as well. So we could come up and say new. We can go into circuit, and what happens is as soon as we bring this up, we're going to see that there's a component library that we have over here on the right. And we can see these are just the basic components. That's all I'm using. All right. And that's going to be exactly fine with what it is we're trying to do. So obviously, we're going to need a breadboard so we can drag that in, drop that in. In this case, with the actual flashlight, we're just using a 3-volt cell, 3-volt battery. So I'm just going to go ahead and drag and drop that in. Now, taking a look here, we can see that our negative bus is here on top. That's our black line, and we can see our positive buses here on the top. But then taking a look at the actual battery, we can see our battery is flipped up. I'm sorry, our positive is flipped up. So we might have to do some rotation here. So that's where this little icon comes in, and we can simply rotate that around and get our positive to hook up with our positive bus and our negative to hook up with our negative bus. All right, so let's just go ahead and start with that. Okay, at any point in time, you can move things. All right, so let's go ahead and let's just add just a standard normal wire, and let's switch our color up to black. And now I can come here to my black terminal of my battery and pull this down, and we can come down and kick this over to our negative bus. Okay, we're going to do the same thing again, but this time we're going to switch this up to red, and we're just going to do a normal wire type, going from here, kicking this up, bringing this up here to our positive bus, and then kicking this over. All right, and now we have our battery hooked up to our breadboard. All right, so in this case, we're going to be needing 3 LEDs. So let's go ahead and just drag those in. Okay, once again with the LEDs. All right, what we can do is we can totally come out and we can rotate those just the same as we did with the battery. Okay, but we can also come out here and we can flip them. All right, we can see that sort of mirror looking image icon. Okay, we can flip them. All right. And what your students are going to be realizing with LEDs, if they were actually playing around with these, is that they're like sort of like one-way valves. It's only going to allow electrical current to go through it one way. So that's really important, and that's why in the presentation when people were trying. To hook up the wires to the battery. If it's not working, it means we need to switch up our polarity of our battery so this could actually flow correctly through the LEDs. So that's kind of why that was in the actual presentation. But so we have our LEDs in here, and I know that they are red. If you ever want to change these and get these to a different color, you have that ability. But I'm going to keep them red, okay, because I feel like that shows up a little bit better. All right, and now what we need to do is get some wiring set up. We're going to switch the color up on this to blue, maybe, and we're just going to say, hey, we're going to hook up our negative bus here to this column 19. All right, and at this point, this is when we could take our LEDs and start dragging those in. So I'm going to be taking, in this case, it's going to be the cathode side. So our cathode is going to be the negative side. And we're just going to start lining these up because these are all wired in parallel. All right, so we have our LEDs hooked up. And let's just see if this actually works. Let's go ahead and now add a wire, okay, from this point here to this point here. And now in order to see if our circuit actually works, we can come up and pick on Start Simulation. And we can see that the LEDs light up. It is giving us and flagging with these exclamation points, which is a little warning to us, but we'll come back and take a look at that. But we can actually see that it works. Okay, so I'm gonna go ahead and stop the simulation. I'm gonna go ahead and just take out this wire. But if you think about with our LED flashlight, we were actually including a switch as well. And you can see there's push button switches and slide switches and so on. But in my case, in the actual flashlight, the project, it was a rocker switch. So I'm just going to go ahead and just use slide switch in this case. I'm just going to take my slide switch. I'm going to bring that in. And I'm going to have that terminal of that switch lined up with our anode side of our LED. Okay, and now once again, I'm going to take a wire from this second terminal here and take it up here to our positive bus. And let's just start the simulation. Okay, we can see it's working. And now when we hit the switch, we can see that things turn on and off. All right, so it's working great. This is the exact circuit that we would have in our LED flashlight. So back to these little indicators. If we just hover over the top of one of these LEDs, we can see that the current that's going through the LED currently is 28.5 milliamps, and the recommendation for this LED is 20 milliamps, which means that we need to decrease the size of the current in order for our LED um, to be stable. All right, we want to give it some lifetime. So that's just going to be a good conversation of understanding what voltage, current, and resistance are. If we want to go in there and slow down the current on it, that means we need to put in some sort of resistance. And right now, there's not enough resistance with our wires and our LED for this to be in its optimal position or optimal working condition is what I should say. All right, so I'm gonna go ahead and just turn this off and stop the simulation. All right, and here's what we can do. We can come in here, we can take out this wire, and now we can go ahead and we can include a resistor. So once again, we can come out here and we can start rotating it. You can also see we can put in a resistor value. But right now, I'm just going to go ahead and drag this onto that second terminal. And now I'm going to go ahead and create a wire that's going to go from this row here up back to our positive bus. Once again, I'm gonna go ahead and start that simulation, and I'm going to go ahead and hit the switch, and we can see that this is working. But we're also gonna be noticing that our LEDs are much dimmer, which means that our resistance value is probably a little bit too high on our resistor. All right, so all we have to do is just pick on the resistor. We can bring this down to just normal ohms, not kilo ohms or anything like that. All right, so right now with 1 ohm, we can see they're very bright, but it's still saying that that is way over the limit. So now we can go ahead and start bumping this up, maybe to 10 ohms. All right, 10 ohms, now it's in working condition, but I want these to be the brightest that they can be without actually tearing up our LED components. So I'm gonna drop this down to 5 ohms. We can still see we're outside of our limit. We get to 5.5. All right, that thing is the brightest it's going to be. Okay, without beating up our components. Okay, we can still come in here, and I don't know if you noticed this by the way, but when you change the resistor value, the color bands also change, which is kind of cool. All right, but this is the point when we can come out. We can try out our switch. LEDs are working. No more exclamation points, no more warning indicators. All right, and now we have just basically replicated the exact circuit that we're using in the LED flashlights. All right, just to see if this is actually a parallel circuit. Okay, we can always just come in here, we can remove an LED. Okay, hit the simulation again, we can see that that is working. All right, but now things are a little bit different because now we got two LEDs and now our current's too much again. All right, so we can stop the simulation, drag a new LED in, make sure that that's wired in correctly. Okay, and then simply start that simulation. All right, so we can see that that all works. Now, going back to flipping the battery and why that may or may not work, well, let's just try it here. Let's just stop the simulation. And what I'm going to do is I'm going to drag this black wire into our positive bus and our positive into our negative bus. So I know it's going to be kind of flip-flopping things with our actual wiring there, but all right, we can clearly see our negatives going to our positive and our positives coming to our negative. Let's go ahead and start the simulation again. We're hitting the switch and nothing is working. Why? Because those diodes are working like a one-way valve. Okay, and we could switch those around and it would be in working order. So there you go. That's just a great way to teach some electrical theory and understanding what's sort of happening within our LED flashlight keychain. What's really kind of cool is here to kind of finish things up is that we're not just looking at the 3D model, but we can also go ahead and send this out to like an electrical schematic. It's going to give kids kind of an understanding of what different sort of component symbols are. All right, we can clearly see the resistors there. We can see the switch, the battery, the LEDs, and so on. So that's going to give them a pretty good indication. But all that is right here within TinkerCAD circuits. It's a great teaching and learning tool. Just want you to be able to see it and how it sort of correlates with our LED flashlight keychain.